Hey everybody, welcome back. Almost said good night, good evening. Dr. Jaws here, and tonight we are meeting a pretty cool wobbegong. It's been a while since we've covered a wobbegong shark, but this is the floral banded wobbegong, Orectolobus floridus. So, wobbegongs are really excellent ambush predators. They are sharks that like to live in coral reefs or other kind of complex environments, so kind of rocky seabeds, areas with a lot of algae, coral, rocks, vegetation. And they like to be in these areas and blend in with their surroundings. So they will lay on the seabed. They have this beautiful patterning and coloration that helps them camouflage impeccably with the background. And they also have, they tend to have these really cool, kind of like fleshy barbels at the front of their mouth, which is theorized to be an attractant for fish. So it's something that looks like a piece of algae or kind of like a piece of seaweed or something that is inviting to a fish, so a fish will go in and get close to the wobbegong's mouth, and then the shark will actually just snap it up instantaneously. So it's actually kind of in a cool way similar to angel sharks. So they're completely different branches of sharks, but they do have a very similar way of living as far as being ambush predators that spend most of their lives on the seabed and lie in wait in camouflage for their prey. So it's a really cool group of sharks. We've said it multiple times on the channel, but this group of sharks, this family, Orectolobidae, the wobegongs, is Steve Irwin's, the late Steve Irwin's favorite group of sharks, or one of his favorites. And he would, typically dive with wobbegong or snorkel with wobegongs in Australia. So something that he really enjoyed doing. So it's really fun to meet these sharks, and I'm excited to learn about this particular species because it's not very well known. So. And I think what we'll do is we'll just dive into some background on the floral banded wobbegong, look up some footage of other wobbegong species. There's no footage on this one in particular, but there are some really great clips of cousins of the floral banded wobbegong, so we can kind of get an idea of like how it might behave or how it moves. And then we'll end with some science, but also maybe some shark paleontology. So, hey Howard, hope everything's going well. Good evening to you too. Hope you had a really good weekend. It's been busy over here, wedding planning, so we're almost done, which is kind of wild. So that was most of my weekend, but hope you had a really good weekend. I actually have been getting more into shark art lately. So I showed that bull shark illustration that I had a couple streams ago. Right now I'm working on a scalloped hammerhead. So local species that are in my backyard in the Mid-Atlantic area of the United States or the Virginia marine ecoregion. So that's been kind of like a fun project. But other than drawing, most of my life has been wedding planning. So a lot of fun, a lot of work, and we're almost there, which is really cool. So this is the second to last stream before the wedding, and then we'll have a little hiatus. So, but hope you had a good weekend. Please leave a comment if you're comfortable in terms of like anything fun or any fun things you did over the weekend. So thank you, really appreciate it. So yeah, and we'll dive in. And I know there's not going to be a lot of information on the floral banded wobbegong, so we're going to do the tail end of the stream, focusing on shark evolution, because I think this is actually a really good family to kind of talk about shark evolution, because it's such a really cool morphology, and it's very different from the classic view of sharks. So I think with that we'll dive in, and actually let's take a look at footage first. So we'll meet the wobbegong family and take a look at what they're like. So this one is wobbegong from Indonesia, I think. Now we'll see if I can identify this one. But this is a cousin of floral banded wobbegong. It's not a floral banded wobbegong. I want to say it's an ornate wobbegong, but let me double check on that. But beautiful shark. Excellent view of the patternation I was talking about earlier, where the rosettes, the blotches, the mix of light and dark, the peppering on the back, it really helps these sharks to blend in with the surroundings. You can actually even see the seabed below the shark is almost like a perfect match to its camouflage. So, oh, nice. Hanao friends stayed up late. That is always fun to do for the weekend. So it was kind of funny. Actually, I did this was 2 weekends ago, but I did finally manage to see not the newest Jurassic World, but the one with the original cast. And it was pretty okay. It had some highs, it had some lows, but there was one character reveal that was a really great tie into the original Jurassic Park. So I think it's called Jurassic World Dominion, but had a lot of fun with it. So, but yeah, let me see if I can identify this Wobbegong species in the clip. So again, it's not the floral banded. It's a little bit larger pectoral fins. This is probably a tasseled Wobbegong because it has distinctively large, two distinctly large second dorsal fins. Nothing else really has the same wide pectoral fins as this one, so this is a tasseled Wobbegong. So again, it's a kind of shark or a group of sharks that like to spend a lot of their time on the seabed and near spatially complex environments, and where they are most at home in terms of hiding and lying in wait to ambush prey. So it's super cool to see just how the shark moves and how beautifully patterned it is and how well it blends into the background. And Wobbegong jaws are very much like bear traps. Angel shark jaws are like this too. It's like once they launch, they're not going to let go. They have very needly teeth, and again, it's kind of like a spring, if you will, where they will just lie in wait comfortably. The eyes are on the top of the head, so they can be maximally observant of the environment around them. And then when a fish gets close to their mouth, they'll snap it up in an instant. So. Also for that reason, both Wobbegongs and angel sharks are actually very feisty, where they do not want to be disturbed. And if a diver gets too close to either a Wobbegong or an angel shark, they will bite. And Wobbegongs have been known to bite divers who make the mistake of just getting too close and touching the shark and otherwise bothering it. So yeah, just interesting to see. Also, this is kind of fun. In this YouTube preview section, I mean, I guess it's biased to each channel, but it's kind of funny that the actual stream is on my recommended videos. It's really funny, actually. So this one's different. This might be an ornate this is spotted Wobbegong. There we go. Sorry, spotted Wobbegong. So, oh, cool. I think I just saw your comment. So, I saw a weird clip on YouTube about an orange nurse shark. Have not researched yet, so I remain skeptical. So I think the orange nurse shark is real. So it is a color. It's a very rare color morph, and let me see if we can look that up. We can actually check it out. Hey, Quackers, welcome back. Hope you had a great weekend. Orange nurse shark. This actually might be a really good exercise as far as kind of finding good sources for information, because I think this is real. Let's see. Because okay. Here's a good example. This is fake. This weird looking white shark with an orange, this is AI in the back. This shark, the nurse shark, I think is real. And it's kind of hard to describe how you can tell. There's something that looks very smooth, clean, and plasticky about the AI white shark, so that's clearly fake. The orange nurse shark, a little bit different. So CBC, we can try that as a source. Let's see what else is here. Because there are examples. Forbes will take that. These are not like direct sources. These are not like scientific sources, but they are publications that will kind of do some vetting as far as New York Times. There we go. Do some vetting in terms of where the information is coming from, because it's so risky to publish something that is like not truthful, because you lose credibility. So sports mission on the coast of Costa Rica caught then promptly released a rare bright orange nurse shark in August 2024. I think there was an article that was describing how it happened, but it is something that happens. There we go. The findings were published. This is what I want. So the nice thing about articles like these is sometimes they do link to the direct source that helps verify what's going on. Okay, let's see. This is Springer Nature, Marine Biodiversity Journal. Okay, so this is an actual verifiable source. So here we go. First record case of free living xanthism in the nurse shark Ginglimostoma serratum. So this is the classic nurse shark, the one that lives in the Atlantic that a lot of Americans are familiar with, and people who live in the Caribbean, the Bahamas, and Mexico, Central and South America. This is a very familiar species. Xanthism, characterized by yellow pigmentation, is rare in marine species and has not previously been reported in cartilaginous fishes in the Caribbean. Here we document the first xanthic nurse shark, Ginglimostoma serratum, recorded in Costa Rican waters. The specimen was captured during a sport fishing trip near Tortuguero National Park at a depth of 37 meters and a water temperature of 31.2 degrees Celsius. That's actually really warm. That's almost like in the 90s. Hold on. Let me see if I can convert that really quick. Celsius to Fahrenheit. Hold on. Celsius to Fahrenheit. That's extremely hot, actually, for water temperature. 31.2. Okay, maybe not extremely. 88 degrees. Kind of on the high side, honestly. That is comfortably above a lot of sharks' maximum temperature ranges, and the tropical sharks they don't have a max. So like hammerheads, they don't have a max temperature. They're comfortable in any kind of warm water. But some other sharks that are more seasonal, their max limit typically is somewhere like 86 degrees. So 80 degrees is a little bit above that. So interesting. But anyway, the adult shark, approximately about 2 meters in total length, which is a very large shark, inhabited intense yellow-orange pigmentation and white eyes, indicating a condition known as albino xanthochromism. This unique finding suggests that xanthism does not hinder survival in the species, which is really cool, actually, because the size attained by the species means, okay, this shark is a great hunter, and it kind of makes sense because nurse sharks don't really rely on camouflage. They're pretty big sharks that kind of stick close to the bottom. They don't really, at least as adults, they don't really rely on camouflage, so it kind of makes sense that the pigmentation difference doesn't really affect it. Compared to previous reports of abnormal pigmentation in Ginglimostoma serratum, such as albinism, piebaldism, and hypomelanosis, this is the first scientifically documented case of total xanthism in the species and the first record from the Caribbean Sea. Further research is needed to explore potential genetic or environmental factors influencing this rare pigmentation anomaly in sharks. So this is by Marioxis Marquez Cuillere, Gilberto Rafael Borges Guzman, and Daniel Arauz Naranjo. So. But it's really cool. No, we don't need an offer from Forbes. I just wanted a photograph of the shark. We'll just go to New York Times. It's really cool to see. I guess this is a paywall here too. So I guess we'll go back to CBC. But it's really cool to see a verified, documented, like real, extraordinary thing in nature. It's amazing to kind of see this. Be a very like a legitimately cool anomaly in sharks. It kind of reminds me, I want to say it was 2011 where there was the Cyclops bull shark. It was a bull shark pup that developed in a different way where there were not two eyes on the side of the head. There was a single eye in the center of the head. And I remember a lot of my colleagues were like when I first heard about this and was sharing this with some of my colleagues, they were like, making fun of me and saying, "Oh yeah, you probably believe in like Bigfoot and something." Like just like they were poking fun of me because they thought it was a fake article that I bought into. And I was like, no, this is real. Like this is you can tell that this is actually a real mutation. And lo and behold, it was actually a and actually we could probably find a photo of this Cyclops shark. Oh, sorry, not the X-Men character. Cyclops bull shark. Okay, so this is a real mutation. So this is a shark that was caught, and I don't think it really. It's kind of funny because you could tell the difference where. like this is stupid. Like this stupid thing over here is not a mutation. This is just idiotic. It's just idiotic edited photos. This is also fake. You can kind of tell it's just like a little too perfect. This photo, this is a real mutation that occurred in the shark, and you can kind of actually tell as far as the character of the eye, just like how it bulges and how it kind of has like the classic chondrichthyan eye. There's something about like the size of the I'm trying to remember, I forget if it's called like the sclera, but like the white area in the eye relative to the pupil. And like just the shape of it. It does kind of have that look. And then when you look at like different angles and kind of consider the date that this was taken and consider that this is something that can happen in nature, this was a documented shark, and a shark that didn't really last long, unfortunately. But it is a very interesting documentation of how mutations can exist in the wild. There is kind of related to that shark with cancer. This white shark. So white sharks with cancer. The infamous myth that sharks don't get cancer was disproven by. And actually, it looks like there's more photos, but I distinctly remember a white shark demonstrated this. And it was the first documented report of a shark getting cancer, which is very significant because shark cartilage used to be sold as, an anti-carcinogen and something that helps prevent cancer, and that's a complete myth. And that actually led to the death of a lot of sharks that were harvested for just a fake pharmaceutical crap. It's just completely nothing. So those extreme things happen in nature. Getting back to the nurse shark with xanthism, kind of considering what can happen as far as mutations go, this is not really surprising. It is surprising in terms of like this is an amazing thing to see, but it's not out of the realm of possibility. And as far as sharks with different colorations go, the only other one I can think of, there are some great hammerheads that have this cool splotchy pigmentation. I don't think it's really an anomaly, but there is such variation in great hammerheads where they can have like the smooth gradient from a dark back and light belly to like these really cool blotchy, almost like great white shark looking pigmentations. And actually, sand tiger sharks have that too, which is kind of interesting. But as far as like unique colors in the ocean, the thing that this immediately reminds me of is blue lobsters, which I'll pull up a picture. And I was actually lucky enough to see a blue lobster in the Seacoast Science Center. There's actually blue lobsters. They have a blue lobster in the tank, and this is actually not an uncommon pigmentation. So this is something that does happen, not often, but. Oh, hey, catching up on comments, hold on. So, we're talking about the orange worst shark. Yes, the shark made it to adulthood. Oh, I'm sorry today was kind of rough, Quackers. I'm like my Monday was kind of like very Monday as well, so I'm glad you're here, and I'm glad that we could talk about sharks together. So I hope this will be, it's always going to be a fun night when we're all together discussing marine biology. But welcome back to the stream, and I'm glad that we get to chill out and talk about weird ocean mutations together. So, yeah, I just saw your comment. What the heck? What did I come back to? Oh, congrats on your new laptop. And Howard, yes, my pleasure. I'm so glad that we got to kind of explore this together, because it's fun to like go through like shark news and separate kind of bunk from real stuff. So it's so cool that we got to talk about the nurse shark and verify that it's real. The one that you guys verified for me was the bonnethead shark with seagrass. I had the hardest time really accepting that juvenile bonnethead sharks can consume seagrass. It just seems so unnatural, but it is something that they can do. So yeah, it's fun to kind of explore these things together. So yeah, but blue lobsters. This is a unique pigmentation that happens in the ocean. And I guess the photos do indicate that it's not as uncommon. I mean, it is uncommon, but it's not like the rarest thing in the world. I think the orange nurse shark is far rarer, but I know there's actually. I don't know if this will be the same thing, but I think I remember a genetic study where they were talking about there was like 3 genes or 3. There's 3 color conditions to make the lobster's normal color. And if you shut one of them off, you're going to get weird looking lobsters like the blue lobster. I think you can get a green lobster, and then I think the rarest is getting a white lobster. So let's see if we can find a white lobster, which is like no pigmentation whatsoever. So, oh, yellow lobsters. Yep. Sorry, I see a yellow lobster here. There we go, yellow lobster right there. So, it's actually really cool. Lobsters are a great animal, and this is the New England lobster. But it's a great animal to study kind of pigmentation in nature and how it could be so variable and how mutations can cause such drastic changes in pigmentation. So, orange nurse shark. But one more look at the orange nurse shark before we get back, because it is such a cool thing, and it's amazing to see this documented in nature. So, and really, it looks like this is like the main photo, the one from that's in the main picture of the CBC article. This looks like it's the main one. So, gorgeous, gorgeous looking shark, beautiful coloration on it actually. So it's wonderful to see this rare individual and to verify that it is real. So let's see, I'll close out of here to kind of save some bandwidth, and we'll go back to wobbegons, which actually, it's actually a good segue. They are cousins of nurse sharks, so this is a spotted wobbegon. And you can actually kind of see some similarities in how they move. I kind of feel like wobbegons, in a funny way, are like the camo nurse sharks, where they, have, like, nurse sharks just have this the solid color, and they tend to swim out in the open. Wobbegons, they are flat like nurse sharks, and they have their mouths right at the front of the head like nurse sharks, but they tend to hide in the seabed and tend to be more, again, ambush predators. They tend to use their camouflage to go hunting for prey. So it's really cool to see a spotted wobbegon on the move, perhaps looking for a good little spot to set its trap, as far as finding a good place to lie in wait. So really cool sharks. This one has a simpler pattern than the other wobbegon, but still nonetheless very complex. A few main launches on the background, and then nice beige to tan. Coloration is white rosettes, or cream color rosettes. So that's really pretty shark. And I love that each wobbegon species has a different patternation, so it's going to be fun to compare these wobbegons to the Floral Banded Wobbegong. We got one more to check out first, is the ornate wobbegon. This is arguably the most famous. I feel like this one is kind of like the poster child of wobbegons. Oh, no ads. Gotta catch up on the comments. Get out here. Skip. There we go. So there we go. There's the ornate wobbegon. So again, one of the most famous wobbegon species. Yes, Howard, 100%. Wobbegons are the ultimate ambush predator. So. Oh yeah, of course. I'm just grateful. I'm gonna star this. Thank you. I'm just grateful to belong to a community where we can explore news items like this. 100%. And we can always do that too, and we can always keep each other honest as well. As far as I think what's really fun about this community is that everybody genuinely cares about sharks, and they genuinely like want to understand them and are passionate about like there's a nice dialogue of like actual factual information, and I really appreciate it as we do our back and forths and kind of verify with each other. So that's so great. And honestly, it's a gift, because when I used to like, I guess not used to, but like it's been a while since I've done like going to trade shows for like book sales and stuff. I would run into some people who were passionate and some people who like really know their shark science, and that they were super fun. And then I would run into people asking me what trench the megalodon live in, and it's like, oh gosh, oh no, that's not right. So I think I just really appreciate this community where we all try to understand sharks as they are, and there's just such an amazing group of animals, and it's really cool to see how variable their lifestyles are and how many different niches they occupy. So we've seen 132 sharks already, which is unbelievable, and it's only about a fifth of them, which is wild to think about. So, like a fifth to maybe a quarter of all known sharks are what we've covered with 132 species, which is just mind-boggling. Case in point, as far as the biodiversity of sharks and just how different they can be and how unique they could be. I mean, look at the behavior of this wobbegong. I think we saw this clip before on the ornate wobbegong episode, but there's just so much personality in this shark. Trying to find a comfortable spot. Clearly very interested in this cave, but also kind of wanting to be aware of the environment around him. So, or her. I think this is a female, actually. So, but a lot of activity, a lot of movement. So, again, they are lying wait ambush predators, but it's really fun to see a member of the wobbegong family just move so much. And, kind of like float with the current. There's a very strong current, and the shark, for the most part, doesn't resist it, and then starts to kind of look for a spot that suits it. So maybe actually it might be kind of attracted to that hollow because the current is so strong, but then, it's not finding the right position. So it's kind of like a big puppy or a big cat, just kind of finding a nice place to curl up into. So it's so cool to see. Beautiful coloration. Speaking of orange sharks, I feel like it looks like the base of this shark is orange with these really cool like black outlines. Beige to even gold patternation in between the orange saddles, and then light rosettes on the back. So just a completely gorgeous animal. And again, you can actually see the barbels, the highly modified barbels and tendrils around the mouth. So I think the last time we examined those, we were talking about how they could be attractants to fish, mistaking those for like algae or seaweed or safe places to kind of swim around, because all fish, they do love structure. They do love like floaty bits or just like things in the water that provide some kind of structure. It is something that attracts fish, and so that might be something for if the shark is lying in complete wait in complete stillness, it might be something that helps it successfully acquire some prey. So speaking of fish, these are beautiful. I'm not sure, because I know Atlantic fish pretty well. Well, okay, I know temperate Atlantic fish pretty well, but this is a whole other place in Australia, and I'm not sure what these fish are, but they're really, really pretty with the horizontal black bars. Very, very pretty fish. It looks like there's some damselfish in there. And it's a cool little guy in the background, and it's well camouflaged. It's going to be hard to point him out, but I love the ridges, like the crests on wobbegongs too. So it probably, like the eyes being perched on top of the head, it's kind of like a frog. It probably helps this animal kind of like keep an eye on its surroundings as it lies, in kind of a relatively low profile on the seabed. So it's just really cool to see. Sorry, great footage. So I think we could probably, it's so cool seeing it swim away. So I think we could probably go ahead and start diving into tonight's species in more detail. So let me zoom in so that we can get a better look. Hold on. There we go. Yes, Howard, just saw your comment. We care about good science, 100%. And actually, what's really cool is for science, there is only good science. Meaning that if science is being done, like if it is actually being performed according to the scientific method, then it's and like in every detail, it is good science. And part of the scientific method is it has to be verified. has to be retestable. It has to be corroborated with others who are given the same conditions and can do the same kind of experiment. Yeah. Sorry, I had some music on in the background that was very pleasant, and I'm trying to get it back on before we dive into the Floral Banded Wobbegong. Oh, on. 1 second. Okay. Oh, so on. Okay. I think my music system is kind of screwing up, but that's okay. If it is, not the biggest deal in the world. We'll just kind of keep going. So, but anyway, the Floral Banded Wobbegong is a small species endemic to Australia. So really cool to see that, because a lot of the famous wobbegong species, including the wobbegons that the late great Steve Irwin swam with, are also native to Australia. So it's really cool to meet a Australian wobbegong species. And this individual, you can kind of tell from the photo, this one is pretty well deceased. The head is very clearly dehydrated, so you could, and very dark pigmentation, so this probably is a little bit further from life. However, you can kind of see some basics where there are two major dark blotches and these beautiful light rosettes that are arranged in kind of this cool hexagonal pattern for each rosette. So almost looking like a flower, which is probably where it gets its name, Floral Banded Wobbegong. The pectoral fins have bare patches at the midpoint, but you have the floral pattern kind of at the insertion of pectoral fins, or origin of the pectoral fins. And then the pelvic fins, similar kind of layout. The dorsal fins actually do have the floral pattern extending to the tips of the dorsal fins, which is really cool. And hopefully we'll get some more photos. The barbels and the tendrils, they seem actually pretty extended. And you can actually see in this photograph very large spiracles, which kind of makes sense for a bottom-dwelling shark. Having a feature, an adaptation that kind of helps assist with breathing, as this is a buccal pumping shark, so it's a shark that's able to actively pump water over its gills in order to breathe. It does not need to swim continuously like other sharks do, so I think the large spiracles kind of help with that adaptation. The Floral Banded Wobbegong is a small species endemic to Australia. This species is known only from a few specimens taken in the intercontinental shelf off southwest Australia. Its biology and habitat use are poorly known, but is thought to mainly live in reef areas. The Floral Banded Wobbegong is minor bycatch component of the Western Australian temperate demersal gillnet and demersal longline fisheries, which only catch approximately 40 tons of wobbegongs per year. In addition, the species is unlikely to be retained due to its small size. The species is also expected to have higher post-release survival, similar to other wobbegongs. So that's actually really interesting, because again, I mentioned at the top of the stream, I've been working on this really cool hammerhead shark drawing, and hammerheads, as I always say, are very sensitive sharks. They're very sensitive to longline fishing, and if they're caught on the hook, they only last for maybe an hour or two. And then they perish, and part of that is because they are very speedy sharks that need to swim constantly in order to pump water over, or have water rushing over their gills, and if they're hindered in any way, they don't do well on the hook. But other sharks, like the wobbegongs and the nurse sharks, they last very long if they're accidentally caught on a hook, because they don't need to swim actively. They could just kind of sit there and actively pump water over their gills, and once a fisherman hauls that catch up and then releases the wobbegong, chances are it's going to be okay, because it does not stress out as much in that kind of situation as other sharks do. So it is interesting to see that quote of the species is expected to have high post-release survival similar to other wobbegongs. It just relates to that, which is pretty interesting. There is no evidence to infer or suspect population decline, although further research is required. Therefore, the species is assessed as least concern. So this is a wobbegong that seems to be doing pretty well. Distribution of the floral banded wobbegong is known only from a limited number of individuals, all taken from the intercontinental shelf off Western Australia between Geraldton and Augusta. So let's kind of look up where that is. And I guess I don't want to like clog up the bandwidth, but I'm just going to take a quick look because I'm curious if that's in a temperate zone, because they were talking about the temperate fishery that sometimes accidentally catches these sharks. So Australia. Geraldton. Cool. Looks like there's only one Geraldton in the world. And it seems to be temperate. So Geraldton, Australia seems to be temperate. Where is Augusta, Australia? Definitely temperate. So that's actually really cool. Okay. Sorry, I did a quick little search on my map app, trying to figure out where this range is. And you know what? I just realized it is absolutely Monday, because I probably could have done that very easily here. So so this is IUCN Red List, which has the map that I was actually looking for. Sorry about that. I should have done this immediately so that you guys could see it. But here is the range of the Floral Banded Wobbegong, and it is in southern Australia. And what's kind of interesting about Australia is that the northern half is definitely tropical, so it's the Australia that, you know, we're all familiar with, you know, kind of pop culture and movies. The Great Barrier Reef is here. So the northern half of Australia, tropical, but the southern half of Australia is temperate. So this actually is a little bit more like think of like a California, or maybe, I don't know about New England, but like definitely like a California. So like a temperate water environment. And it's really cool to see that the Floral Banded Wobbegong lives here, because in temperate environments, you're probably not going to expect as much coral, and you know it's very unlikely to see coral reefs, but you might be expecting more rocky kelp seabeds. And it's kind of cool to see the Floral Banded Wobbegong's coloration in respect to that. So the pattern is a little bit darker, maybe not as complex as the other wobbegong species, so that might be an adaptation that kind of helps blend in best with its environment in the temperate zone. So pretty cool stuff. Let's see what IUCN Red List has to say. So it also says the species is least concern, which is fantastic to see. And we could take a look at the assessment in detail. So it's always great to see. I love seeing sharks that are actually doing pretty okay, because many sharks, as we all know, are suffering fishing pressure. Overfishing is probably the single greatest problem. Overfishing and habitat destruction. So specifically, like building shrimp farms or beach houses in areas that used to be mangroves. You know, these are destructive practices that hurt shark nurseries, or you know, overfishing. For a lot of the fish that we buy at the grocery store, we have to be careful where it comes from, because you know sometimes it's, you know, not from a sustainable source and can actually directly contribute to bycatch, where people are accidentally catching sharks and driving their extinction. So many sharks are not doing well in those conditions, but it's really cool to see that the Floral Banded Wobbegong is actually least concern. I just saw your comment, Howard, about small range. That's actually even better, that the species is least concern and the range is very small. So this is kind of, you can argue it might be an endemic species. And we can actually take a look at the ecoregion map. Yeah, I mean, small range, I'm kind of curious if it crosses multiple ecoregions. So let's see, marine ecoregions of the world. There is data basin, that's what I wanted. This is a really great source. Let's see, here we go, open a map. And I'm going to post this in the chat. This is such a fun app to play with, but Marine Ecoregions of the World is a map provided by Data Basin. It's a map of really great subdivisions of the ocean, and it's kind of like a conservation tool where you can actually predict certain patterns, or like there's certain parts of the ocean that have certain patterns or certain physical features that create a unique environment that within the ecoregion itself is fairly predictable. So that way, if you kind of approach management and conservation from an ecoregion perspective, it kind of helps you know, I identify like key areas to target for protection measures and have the best result possible in terms of making sure that every unique area is covered. So let me go back to kind of simultaneously troubleshooting my music stuff. So, but for the flower wobegon's range, we can kind of cross-reference this ecoregion map with the range map from IUCN Red List. So there we go, music back on. It's kind of missing that. Okay. So on this map, where the wobegon lives, looks like it's kind of near this area. So extend down past the Darling Scarp. So for Australia, it looks like this shark occupies 2 ecoregions. Specifically, this one, which is the Houtman ecoregion, which is temperate Australia, or temperate Australasia. So what's really cool again about these ecoregions is that they're nested, where each ecoregion belongs to a larger province, which belongs to a larger realm. So the province is Western and Central Australian Shelf. The realm is temperate Australasia, and that's the thing I wanted to kind of figure out: is this a truly temperate species? And it looks like it is. So it lives in the temperate parts of Australia, not the tropical parts, which is pretty cool to observe. The other ecoregion it lives in is the Leeuwin ecoregion, which is in the southwest Australian shelf, and this is also part of temperate Australasia. So this species of wobegon is a truly temperate species. So. The Floral Banded Wobbegong, I'm just going to zoom here so you guys can see it. There we go. The Floral Banded Wobbegong, Orectolobus floridus, is a recently described small species endemic to Australia. This wobbegong is known only from a few specimens taken from the intercontinental shelf off southwest Australia between Geraldton and Augusta at depths of 42 to 85 meters. So it's a pretty shallow water shark, and it makes sense because wobbegons are so well camouflaged that it probably benefits from living in a well-lit environment where that camouflage really pays off. If it had this beautiful floral pattern but lived in the abyss, it kind of doesn't really make any sense because the abyss is universally dark, right? Save for bioluminescence. But if it has that floral pattern and lives in a coral reef where there's light bouncing everywhere and light illuminating all these like bright spots and dark crevices and shadows, like the complex pattern of the wobbegong really helps helps the species to survive in that environment. So really cool. It makes sense that it's a shallow water shark. Its biology and habitat are poorly known, but it's thought to mainly live in reef areas. When they say reef, it doesn't necessarily have to be a coral reef. There's a lot of different ways a reef can form. So coral reef is the most famous, but you can also have oyster reefs or rocky reefs. So rocky reefs being just literally stones or slabs or just rocks and pebbles, arranged in such a way where communities can still form and they will grow on these rocks and actually build a structurally complex environment. So yes, Howard, shout out to Australian conservation practices, 100%. I would say, as far as like science goes, I think the classic. There's a lot of. I know I've said this before, but like as far as shark science goes, I think the United States and Australia were kind of the leaders. And special shout out to Brazil, South Africa, and I I think India, and Japan, but mostly Australia and the United States. They did have done really great shark research, but I will say that as far as shark conservation, I kind of feel like Australia might take the cake as far as like we've seen multiple times that there's Australian practices that actually help sharks that live in Australia that like it's the same species that in Australia it's doing very well, but in nearby countries it's like kind of crashing. So I completely agree with Howard. Shout out to Australian conservation practices, and I will say Australia might be the conservation leader. Maybe 10, 20 years ago, I would say the United States and Australia are both good shark conservation leaders, but I would say Australia, I think they still probably produce good science, but as far as conservation, I think Australia probably edges out as far as creating just really great measures that help species, that help shark species. But it's not a firm title to hold. Where I think a lot of other countries are trying, and a lot of other nations actually do have some really cool practices and ways to kind of help sharks. Bahamas, as an example, they do a lot of ecotourism, but they also have one of the world's most famous shark labs, the Bimini Biological Field Station, and so and they treat those sharks with such reverence that it's like other countries have contributed very much to the world of shark conservation and shark research. So, but yeah, sorry, I'm kind of rambling. Shout out to Australia, though. I definitely agree, and I really appreciated a lot of what they do because it's worked. There are so many shark species that do live in Australia that actually do well because of marine protected areas and how they're managed there. So, let's see. Although little is known about the biology of the species, the Floral Banded Wobbegong is a minor bycatch component of the Western Australian temperate demersal gillnet and demersal longline fisheries, which only catch 40 tons of wobbegons per year. So I think the other article we're reading probably it looks like it's the same as this, so they probably both are using the IUCN Red List as a source. In addition, the species is unlikely to be retained due to its small size, expected high post-release survival of wobbegons. So yeah, it's kind of like the same information, but still very important information. Further research is required on species biology, occurrence, and capture in fisheries, but there is no evidence to infer or suspect population decline, and therefore the species is listed as least concern. So it's wonderful to see a shark that is actually doing pretty okay. And one of my favorite parts of our stream is that we've given attention to the sharks that are doing really poorly, but it's also we've found some reassurance in the sharks that are actually doing okay, where it's like a third of sharks are doing very poorly, a third are like kind of in this gray area, I feel, as far as like they're kind of alright, but there's something about its biology that is a cause for concern. And then a third of sharks are actually okay. Like they're actually, relatively speaking, doing okay. Some of them are actually even growing in population. I've been shocked to learn a few of the shark species that have grown in population, and part of it could be predator release, unfortunately, where as large sharks or large predators are fished out, it does create spaces for smaller predators, but it's not good ecologically. So there should be an award recognition. It'd actually be cool. Sorry, I just saw your comment, Howard. Should be a reward recognition, like an international reward for shark conservation. That honestly would be really, really cool, and I would really love that. It's interesting where I feel like there's a lot of potential for shark conservation to kind of... It has such a strong presence. We talked about this maybe a month ago, where we were talking about like the Save the Whales movement and how that gained so much momentum and really established a lot of change as far as like how we look at whales and also how we legally approach whales, where whales have like all the protections, and there's room for probably more protection, especially in other countries. There's definitely areas of opportunity in terms of whale protection, but when you compare whales to other marine life, they have so much going on for them as far as like the cultural reverence, but also the legal protection. There's so many laws. I mean, even that extent to like every boat or every vessel regarding whales, depending on where you are. You have to like, you really actually have to. You get in real trouble real quick if you like exceed a certain speed limit in a critical whale habitat, like right whale habitat or killer whale habitat. You got to be really careful and respectful of that. So what's interesting is like I don't think we're there with sharks yet, but I feel like such massive pieces of just shark culture and shark conservation and language and shark conservation measures have like happened and are in place. Where the some countries have this, like the ban on finning is very firmly established ever since the 90s in some areas, so that's like a big piece. I will say, as irritating as Shark Week can be for all the wrong reasons, it's also been an effective platform to talk about shark biology, and they do feature some legitimate shark science, which is great. It's kind of like they do this weird dance of like actual shark science and then just complete gobbledygook crap. But like, but they do at the end of the day showcase some legitimate shark scientists talking about sharks. And I think with the advent of like YouTube and social media, there's so much more interest, and it's so much easier to share, not just kind of like what we do with outreach, but also, I mean, just like scuba divers encountering these animals and just enjoying them and just sharing videos and photos of them. I just feel like there's a lot of really cool pieces in place, and I think as time goes on, they might kind of unify a little bit and kind of build this really cool, like solid message of sharks are reverential animals. Like they're just very special and deserve a lot of protection and deserve a reverence that is similar to the reverence that we give whales. Like whales are treated like panda bears. I think like there's such a reverence there, and there's such a poster child of conservation, to the point where like I remember Tropic Thunder made a joke about and I don't really like that movie, but there's a movie in the late 2000s, Tropic Thunder, that made a joke about killing a panda bear. And the reason that joke is funny is because it's like killing a unicorn. It's such a sacrilegious thing to do because pandas are so revered and like are the poster child of conservation. Similarly, I think whales are at that status, and I think sharks one day will be there. And I don't know when that will happen, but I do think that will happen. So it's going to be interesting to see, but so much dialogue has happened already that I think it is actually a possibility, so that sharks will have that recognition that they deserve. I mean, they're just beautiful animals. They've withstood millennia of change and time, and just have completely outlived us and will outlive us, after humans evolve into whatever is next. It's kind of amazing to just see, like 400 million years of evolution for sharks, and we haven't been here nearly anywhere as long. It's just such an amazing group of animals that just deserve so much reverence. So I'm kind of rambling, sorry, but we'll keep going with the Floral Banded Wobbegong. And I think we'll hop over to our good friend Fishbase to see if there's any more facts. Yes, I love this comment, Howard. Overall, Shark Week has performed a service by increasing awareness to the public. I agree. And also, I will say that it's kind of taking me... My opinion has evolved a lot, where in the 90s and the 2000s, it legitimately was good. It was legitimately like this cool, like, exploration kind of thing, where and I think that was the vibe of Discovery Channel. It was like, come with me, we're going to show you these really cool corners of the world. Science is cool, nature is cool, come learn. It's just like, that was the vibe. It was so cool, and Shark Week used to be 100%, I think, in that Discovery Channel vibe of the 90s and the 2000s. It was legitimately like the channel to discover things, like literally like celebrating actual human discovery, like celebrating like knowledge, you know. And then it just got really bad, I would say the late 2000s and the early 10s, and just so much stuff that is just sensationalistic that I think coincidentally rose with reality TV, where it was just getting dumber, it was getting more fake, it was getting like people were stringing these narratives that didn't make any sense, like making up shark behaviors that didn't exist, just to kind of sell a story. It's terrible. It was terrible what was happening to it, and I think that drew a lot of backlash and a lot of ire, and for myself included. Culminating in that 2013 Megalodon documentary with fake scientists. Like they're not even scientists; they're actors, and they disclaimed that they're actors at the very end of it. It's not even a documentary. It's just like a movie, like a zombie movie. It's just completely fake, right? And they've done this before. They did one about dragons. They did one about mermaids, and there was one more group of like just fake stuff that they did. Like I don't know if they did Loch Ness monster stuff, but like they've done a lot of weird stuff because it sells, because it's like attractive to viewers who may not know any better, and you know that understandably drew a lot of backlash. And then I want to say, I think in the 2010s through 2020s, I don't think they really rebranded. I think they kept a lot of the crappy elements, but I think they infused them and with more science elements, and they beefed up the programming with legitimate scientists exploring like alien sharks. Alien sharks is a great example where it's a great showcase of deep water shark species that are, you know, legitimately, you know, cool and like don't have a lot of coverage. I think they actually did a special on oceanic white tips, which is really important because that was a critically endangered species. It still is a critically endangered species. So they honestly, overall, like now that we're way past 2013, and when I look at the bad versus the good, and I definitely agree, Howard, they were running out of material, you know, like, and unfortunately that's what they had to do. Like Shark Week was such a moneymaker. It's I think, correct me if I'm wrong, I think it was like the #1 program in television. Like it was like, Shark Week holds some kind of unique title where it's like the #1 tuned in event or something like that. And with that, there's a lot of advertisement, opportunity. And I guess Discovery Channel was kind of in this weird position of like, oh, we got to keep the gravy train rolling, and what are we going to do? You know, like how we're going to keep people interested. And unfortunately, someone made the decision to just make it dumber and to make it more sensationalist and not really about sharks, just more about like a story, you know, like a fairy tale, like great white shark serial killer is just terrible, where it's like sharks aren't serial killers, they just, you know, it's like that was weird. The Megalodon thing was the worst. Like it's just weird stuff. I mean, weird, like there's one terrible one where like it was these two white sharks that just coincidentally were in the same area, and some guy said, "Oh my God, they're brothers, they're siblings," and it's like, no, they're not. Like, how in the world can you determine that from how they look? And I don't think they did any genetic testing or anything. It just was a story that sold. It's just dumb stuff. So, sorry. So the bad is bad, but yes, some of their prehistoric shark specials were awesome. Yes, like the bad is bad, but the good is good. And when you kind of like go through time, it's not to excuse the misinformation, because I don't want to do that, because it does matter. But as you go through the total picture of Discovery Channel and Shark Week, you know, as time goes on, it's like, well, I mean, they did at the end of the day provide a platform for unique shark content. So it is extremely popular, 100%. You know, at the end of the day, it would be kind of cool to make like I wonder if they'll make like a DVD collection, or not a DVD collection. Sorry, what am I saying? Like, we're way past that. A streaming collection, because those have been actually really fun. It would be really cool to see if they make a streaming collection of high quality shark documentaries, or someone did a curated playlist or a curated collection of like like very well reviewed, very well respected shark documentaries that actually talk about the science. So, and I agree, Howard, clickbait absolutely sucks. What I'm not concerned about yet because I haven't seen it yet, but I am a little, like, switching topics from Discovery. I am a little concerned about AI stuff. I'm not there yet. I have not. Like, AI has been really weird, where I kind of feel like it was gaining some ground as far as like weird AI entertainment or AI generated shark crap. I feel like some of it was gaining some ground in the early part of this year and maybe late last year, and I feel like, I don't know if it's just me, but I kind of feel like it's hasn't maintained that momentum, which is good. It's good that it's not really like, because like when I look for footage or look for sharks to review, I don't see a lot of it. I see mostly like actual, verifiable, pieces of film of, just different shark species. So, on a note of clickbait, I will say shark, like if you're trying to like look up shark attack information or shark bite information, that's really hard to find accurate information because that stuff has turned into an AI nightmare, But everything else, like as far as like actual shark biology, so far it seems pretty unscathed, and I'm very grateful for that. So just, yeah. Sorry, that was a long way of saying clickbait sucks. I definitely agree. So I just want to make sure I address every comment. Whales and dolphins are the golden boys of marine conservation. Definitely agree. The only reason I laugh is I forget if I shared the story, but I feel like I did. I feel like I shared this maybe a year ago, but there was for anybody who's frustrated with dolphins or whales, and like I'm not. I mean I like, but it's a common thing in marine science. Like a lot of marine biologists are sick of dolphins and whales because of exactly what you said. They're the poster children of marine conservation. Like they are the thing you think of when you think of marine biology. So they take the spotlight away from like worms, hermit crabs, little reef fish, drums, like things that they don't have that much popularity, but they're very important parts of the ecosystem, right? And what's kind of funny is for anybody who doesn't like the dolphins and the whales or gets irritated by them, I have a story for you where somebody told me once one study that they've done on dolphins or monitoring a dolphin population. It was a population study, and what they had to do was they had to collect tissue samples. And dolphins, as you know, are very fast animals. They do love bow riding. So like when boats are going really fast through the water, the dolphins like love to be near the boats. And like it's something that attracts them. Otherwise, like there's not really a way to kind of get them to come close. So this group of scientists, what they did was, okay, we need to get tissue samples from dolphins. We can't really fish for them. I guess what we can do is take an empty shotgun shell case and go to the bow of a boat and then, get a tissue sample from a dolphin in the most horrible way possible. And it's just like, it's really bad, but there's something kind of in a weird way is a little funny. I mean, I shouldn't say that. I know that sounds completely awful and deranged, but when they first told me that story, the younger me was starting to just crack up laughing, and I'm so sorry. I know that's really terrible, but like, it's just like, it goes back to, it's like the classic golden child of like the golden boy of marine conservation, and the only way you can safely and undisturbedly get tissue samples, like tissue plugs of dolphins, is to take a shotgun to them when they're bow riding. It's so terrible. It's so terrible. It ultimately helps the dolphins because like the tissue plugs, when they're shot at the dolphin, they immediately come out and they can be collected later, and you can monitor things like, okay, how many toxins are in the tissues here? like what is the blood like what are the hormones that we can see in terms of like what is the stress level like what like there's a lot you can actually tell from that. You can also take DNA from that and kind of like actually assess some greater population questions. So it ultimately benefits them, but it's so heinous that it's just there's some dark comedy in there. So anyway, moving on back to the Floral Wobbegong. I think if they looked at the YouTube community, sorry, I love this comment. I think that if they looked at the YouTube community, they would realize there are many great sources for great content. Yes, 100%. YouTube is so funny too, where when it first started, it was just, I think, enthusiasts, kind of like this channel. This is like a hobby enthusiast, well, not a hobby, but like this is a passionate outreach channel where we are all very enthusiastic about sharks. So this is kind of exactly what YouTube is for. It's a community of like-minded people sharing space, so this is great. And original YouTube was like this, and it still exists, but I think ever since PewDiePie made millions of dollars, it started to draw the attention. And I shouldn't blame PewDiePie squarely. It's like there's other YouTubers that were doing let's plays and things that started to make media and corporations realize, wow, you can make a lot of money on this. So that generated a lot of interest and a lot of people jumping on the platform and then making these giant, stupid, clickbaity things. And unfortunately, like it's everywhere, and it kind of like dominates the content. But the really cool enthusiasm channels, like the really cool we're actually passionate about a subject and we're gonna talk about it together and share space together, still exist. And I just wanted to I totally agree with you that if you look at the YouTube community, you realize there are many great sources for great content. 100%. There's these awesome fossil channels on YouTube, dinosaur channels, shark channels. There's a lot of great content out there. So yeah, sorry, just wanted to completely affirm that. Definitely agree with that. So yeah, we'll continue with the Floral Banded Wobbegong. I think we'll take a look at fish base, and then I think there might be some specific Wobbegong studies that we'll take a brief look at, and then we'll talk about shark evolution. But Floral Banded Wobbegong, they have actually, ironically, a nurse shark placeholder photo because there's no image available for this species. So it's that's how unknown it is as far as its biology and conservation. The name comes from Orectos, which means stretched out, and lobus, which means rounded projections or protuberance, referring to the long nasal barbels. So Orectolobus means stretched out nasal barbels, so that's a great Latin name for wobbegons, actually. That's where they get their family name too, Orectolobidae. So it totally makes sense. Floridus is Latin for full of flowers. So that is like Florida. That's exactly where Florida, the U.S. state of Florida, gets its name from, referring to the rich floral pattern of bands and blotches on the dorsal surface. So I think we did have an image of that. So unfortunately, hopefully we can get some more. I think there are some more images. I think a set over somewhere. Hold on. I am pretty sure I had some Floral Wobbegong images. There we go. Okay, so there's a Floral Wobbegong, Orectolobus floridus. So this is actually great to see it in life, and we can actually take a look, at some of how this shark looks. So here we go. Let's check it out and take a look at the floral patterns too. So you got these actually really cool eyes, almost like reptilian looking eyes. So this very fun triangular pupil. Beautiful little barbels here and lobes here, so mimicking algae, not as ornate as the tassel wobbegong or the ornate wobbegong, but still there. Got these really cute dark spots, kind of like a almost like a I was about to say zebra shark. So I was about to say leopard shark, and I realized that's not quite correct. light speckles here. Hopefully, if we get another photo, we might be able to see what it looks like the body. But still got that classic look. This is a great photo of the floral wobbegong's face. So and head. It's really cool to see the raised eyes. So again, kind of like a frog. The eyes are on top of the head to kind of help monitor any fish that's swimming by, as it keeps a low profile, flattened against the seabed. And let's take a look. This might be one in life. Here we go. Yes. Oh, and actually you can see it. Okay. Here we go. So you can actually see where the pattern comes from. So here we go. Also, hello Ray. Welcome. Welcome to the channel. So it's exciting to have a new viewer. So, and thank you for letting me know. Sorry about that. So sometime, well, actually, as the community will let you know, I don't know what it is about the mic, but it does act up. So sorry about that. I start to sound like a robot every now and then. So, but yeah, welcome. We're glad to have you here. If you're comfortable, please feel free to share what country you are viewing from. As you can see, kind of on the bottom bar, I have flags from around the world. These are viewers from the interwebs. So we have United States, Canada, Netherlands, Russia, Indonesia, and I'm sorry, hold on. United States, Canada, Indonesia, Netherlands, India, Russia, Norway. There we go. So sorry, I got some flags mixed up. So, but that's where the bar refers to. So anyway, but it's really cool to see the floral wobbegong here in this photograph. I know it's a little blurry, but you can actually see the floral pattern. So awesome. Welcome. I am also American, and welcome to the channel. So I'm on the East Coast. So I'm specifically in Virginia. So I have a passion for the Chesapeake Bay region, and actually really more like the general Mid-Atlantic region, specifically the Virginian marine ecoregion from its Cape Cod, Massachusetts to Cape Hatteras, North Carolina is like the typical definition. So it's a really cool temperate zone that has a lot of migratory sharks. So in the summer we kind of mimic a tropical-ish environment with bull sharks, hammerheads, spinner sharks, blacktips. And then in the winter we've got these really cool cold water species like basking sharks, pike dogfish, great whites, and makos and porbeagles. Makos and porbeagles, makos and great whites, they do live here relatively year-round, but they're very rare. But we do get them. So it's a really cool region that has a lot of biodiversity and a lot of seasonality. So I'm passionate about sharks from around the world, but that region in particular is really near and dear to my heart. So yeah. Oh, thank you. I found your channel a while back, looking up shark stuff. First time joining a stream, though. Oh, thank you. Yeah, I hope you enjoy it. And we always pick a new species together towards the end of the stream. So feel free to leave any, if there's a particular shark you want to learn about, feel free to leave any suggestions in the chat. We've covered 132 species already, so some of the charismatic ones might be done. So we did great whites, we did tiger sharks, but there's a bunch of other sharks to learn. So if you have a couple ideas, please feel free to share them in the chat. And same for you, Howard, or any other viewers. It's not quite 10:30 yet, but feel free to. I think we're kind of deep enough into the sharks where it probably is good to throw out a couple of suggestions as opposed to one suggestion, because chances are we've covered a species already, and we'll kind of go from there. So, but again, welcome. Glad to have you here. So for this photo of the floral banded wobbegong, it's really cool to see just the pattern where it gets its name. So where it does have kind of I know this photo is a little difficult to see, but it kind of has like the rosettes kind of make petal shapes. Almost like a what do you call that? It's so dumb. It's like a 5-star pattern, not a pentagon, but a 5-star pattern of rosettes. So kind of radiating from a central point. So it's kind of cool to see that. And it's really fun to see that there's this beautiful dark orange kind of base. Getting back to orange sharks, it's kind of cool to see that in the background, and then the white or light colored rosettes just around the shark. So this is also an interesting tank. I'm assuming this is a tank. Well, I don't know. I can't tell if this is a tank or if this is a reef environment. This could be a reef environment, but why this is interesting is like you've got the wobbegong back here, but there's something in the foreground, and I actually can't quite tell what this is. It almost looks like an eel of some kind, which is it's very weird to see. And please let me know in the comments if you have an idea of what this animal might be. But like, there's some large animal here that does have a fin. But it has this like very long, what appears to be a dorsal fin, and there's no shallow water shark that has a fin like that. There's the deep water frilled shark that has a single long dorsal fin, but for shallow water sharks, there isn't a shark that actually has this kind of feature. So I'm gonna guess this is like maybe some kind of like eel, but if so, it's very large. But then again, this is a kind of a small wobbegong species, so maybe this is just a photo of a small wobbegong and a large eel. But yeah, let me know in the comments if you have an idea of what this animal is. It's very strange looking, just from this single angle, so I'm kind of curious what that is actually. But still, really cool photograph of the floral banded wobbegong in the wild. So even though we don't have footage of it, it's actually really cool to see a photo of it in life, because we have this photo of a deceased individual. It shows us a complete individual, but unfortunately not in a condition. Wish I can get rid of this little X, but unfortunately not in a condition where we can determine a lot of like what the actual true colors will be, because when fish are preserved, their colors fade or darken. So it's kind of hard to get that lifelike coloration, but it's really cool to see sharks in life, or photos of the wobbegong in life, where you can kind of see those colors really shine, and just really beautiful species overall. I think what we might do next is I'll hop around to see if there's any wobbegong specific research, and if not, it might be a good opportunity to talk about shark evolution. So let's see, this is kind of more general shark stuff. This I think is this is cool. This I think is the genetic map study. We won't spend too much time on this, but this one is actually really cool, showing it's like a radial chart of how sharks and rays are related. I will put this one, get out of here. I will put this one in the chat because it's a pretty... is this Ken and Kashino? No, this is something different. A DNA sequence-based approach to identification of shark array species and its implication for global allows to bring diversity and parasitology. I'll still put this one in the chat, because this one is actually a pretty cool study talking about total shark biodiversity and how sharks relate to one another. I don't know if this is going to show us any specific information about the floral banded wobbegong, so I might move on. But this is still a very cool shark study, so I'll just leave that in the chat. This one's more general, body form in sharks. This one is also general, and when I say general, I mean like sharks around the world, but not really the wobbegong specifically. This study is actually really cool. I'll post this in the chat too. We've seen this chart a couple times, but I always think it's fascinating to look at. This is a circle phylogenetic tree, or a complete circle phylogenetic tree of not every shark species, but a lot of them, to kind of understand of how how all sharks relate evolutionarily. So there's two main branches of sharks: the squalomorphs and the galeomorphs. So the squalomorphs are kind of the it's terrible. This is not the right way to say it, but they're kind of like the older sharks, if you will. They have more primitive features. I mean, all sharks are technically primitive, or as primitive as evolved, because they're all here contemporaneously. But on the left is the galeomorphs, which kind of have more of like the modern looking sharks, like the hammerheads. But the Wobegongs are over here. So, like, I guess the only major takeaway is like there's two main big branches of sharks: squalomorphs and galeomorphs. Of the galeomorphs, you have a few different orders. One of them being Orectolobiforms, which is over here. This branched off from all the other galeomorphs. So it branched off from great white sharks. It branched off from bull sharks. It branched off from cat sharks. A lot of like the classic sharks that we think of. Into this corner. So this is the Orectolobiforms here. So these are... Oh, and actually heterodontiforms too. So the bullhead sharks. So the bullhead sharks are actually fairly closely related to, or kind of their own branch. And then from within that common ancestor, the Orectolobiforms kind of made their own group. And here you can actually see these two big wings. You've got the Wobegongs here as one wing. And then you've got the nurse sharks, carpet sharks, and whale sharks as another wing. So it's actually kind of cool to see that within the order Orectolobiforms, Wobegongs are kind of like their own group, and they're analogous, or like they're as closely related to each other as nurse sharks, whale sharks, and carpet sharks are related to each other. So they're evolutionarily kind of removed and kind of like their own thing, pretty distinctly. What's actually really cool is you can see here that if this is, I don't know if they did this phylogenetic tree. I was going to say, it looks like these sharks are actually really closely related. They don't have like deep time diversification as like the other sharks, but that might not be correct. So I'm not 100% sure about that actually. So, but it's actually really cool to see like how like the Wobegongs are just like their own little branch here, and all the other Orectolobiforms are kind of grouped together, but not with the Wobegongs. So Howard asks, have we done the starry smoothhound? I'm gonna check that. Let's see. That's a good one. That would be a great one to cover because it's been a while since we've done a smoothhound. Let's see. So I'm going to check. I'm glad I made shark order playlists where I have all the sharks organized by their orders, like their taxonomic orders. So we did the dusky smoothhound. We did the taupe shark. Let's see. Weasel sharks, leopard shark, sailback hound shark. I forgot we did that one actually. We did do the starry smoothhound. That's a good suggestion. We actually did that 6 months ago. So, but there's plenty of smoothhounds to cover. So let's actually choose a new smoothhound. Because that's a really good group. So let's see. Okay, I think I've actually got a good one. Oh, actually. Oh yeah, Ray. Hard to believe there are that many sharks. It's really wild. There's like, when I was a kid, there was about 300 species, and then now there is 540, and I think the number is going to keep growing. So there's actually a couple really good candidates. Just quite a few smoothhounds. I'm just double checking who we covered. Okay, and thank you, bear with me, thank you for your patience, because I'm just trying to make sure I'm going through the entire list. Okay, so I've got 2 suggestions. Okay, great. Okay, I've got 2 suggestions. Oh, with how big the ocean is a bet. Yeah, absolutely. So, so one thing I've shared, I do have a prediction. This is a gut feeling not scientifically verified prediction. This is just me, but I actually predict when all is said and done, there's going to be 1,000 shark species. Like that is my prediction, and the reason there's a couple reasons why. As genetics has gotten better, I think, or like not I think, we have discovered some species hiding in plain sight. So the best example is the Carolina hammerhead. So there used to be just the scalloped hammerhead, but scientists recently realized that there's actually a group of hammerheads that look almost identical to the scalloped hammerhead, but I think they have a couple less vertebrae than the scalloped hammerhead, and they actually don't breed. Well, they do hybridize with scalloped hammerhead, so it's really confusing, but they actually are so genetically distant that they are actually their own species, and that is the Carolina hammerhead. So it's a very difficult species to identify, and it's actually I think it's virtually impossible to identify in the wild, unfortunately, because it looks so similar to scalloped hammerhead, but it is a distinct species. Similarly, bull sharks have been theorized to be 3 shark species under one name. So like there's 3 populations of bull sharks that are actually distinct enough that they might be different species, which is so cool to think about. So the one in the Atlantic is a separate population from the one in South Africa, is a separate population from Pacific bull sharks. So which is really cool. So I feel like there are actually a couple of species hiding in plain sight, and they're called species complexes. So as those get resolved, that might add to the total count of sharks. The other thing too is that there's actually still a lot of the ocean we have not explored, and with that, there's a lot of deep water areas that we don't really know what's in there, and not megalodon, like that's not going to be in there, because that is a prehistoric shark that used to hunt whales of enormous size, and it's just like it went extinct because it no longer could like sustain itself. With like it got kind of outcompeted by white sharks ultimately. So in this day and age, that kind of animal would have been seen, and there's just no way you can. It just doesn't exist anymore. It used to, but it doesn't exist anymore. But that being said, there are a lot of smaller deepwater sharks that we have not yet met. There's a bunch of different kinds of cat sharks, a bunch of different kinds of lantern sharks, and I think we're just beginning. Well, maybe not beginning, but like it's going to be an ongoing journey. I think we're going to keep discovering new species, because there's just so many parts of the ocean that just have not been really touched, as far as, which is very comforting, I think, because I think there's an illusion that we know everything and that we've seen everything, but in reality there's actually a lot that we don't know about sharks still, and a lot of areas that just, whether it's like funding or inaccessibility or whatever, they just aren't really as explored. So it's really cool to think about that. I think when all is said and done, there's going to be 1,000 species. That's my prediction. I'm just blown away by how much has been discovered in like even 20 years, So, but anyway, so Howard suggested the starry smoothhound. We've already did that species, but we've got 2 really good candidates. And I'll let you guys decide. They're very similar. They're also a kind of smoothhound with a starry pattern. We've got the gummy shark, which I think lives in. So it also lives in Australia. I think gummy sharks could be found in Antarctica, but in like northern Antarctica. But Mustelus antarcticus is one species that we could do. So it is. Oh, sorry, misspelled that. Mustelus antarcticus. There we go. So it's one species we could do. The other one, which is closely related, is the rig, which is a really cool name. It sounds kind of badass, actually. They look very similar. This one is in New Zealand, so the rig is Mustelus lenticulatus. So these are 2 kinds of smoothhounds. We can definitely cover one next week, so let me know what you think. Do we do the gummy shark or the rig? Gummy shark is a species I've heard of before. I don't know much about it, but I have heard of gummy sharks before. I've never heard of a rig. So Yeah. Let me know what you guys think as far as next week's shark. I think with that, we'll transition to shark evolution because I don't think I have. Make sure I'm not missing any. Let's see. I guess there is one wobbegong study, so here we go. Recent shark radiation, molecular phylogeny, biogeography, and speciation of wobbegong sharks. Let's see. So this is by Shannon Corrigan and Luciano B. Beheregeri. Okay. The elasmobranch fish are an ancient, evolutionary, successful, but under-researched vertebrate group, particularly in regard to their recent evolutionary history. Their lineage has survived 4 mass extinction events. The most present-day taxa are thought to be derived from Mesozoic forms. Here we present a molecular phylogenetic analysis of the family Orectolobidae that provides evidence for recent events of diversification in this shark group. Species interrelationships in Orectolobidae were reconstructed based on 4 mitochondrial nuclear genes. In line with previous morphological work, our results do not support current taxonomic arrangements in Orectolobidae, indicate that a taxonomic revision of the family is warranted. So that's exciting, and this is very prevalent in shark history, which is shark families have been rearranged and reorganized and reclassified a lot. The most recent major revisions have been sand tiger sharks are treated as their own family. So Cocaridae is not the same as Odontaspididae. So there originally were 3 sand tiger sharks: the sand tiger, the small tooth sand tiger, and the big eye sand tiger. And we recently determined that the sand tiger shark is kind of very unique, and it's kind of its own family. And the other 2 sand tigers are their own family as well. The other one that's even bigger is the tiger shark. So tiger sharks used to be classified as carcharinids. They used to be classified as requiem sharks in the same family as sandbar sharks and bull sharks and blacktip sharks and lemon sharks. And we realized that tiger sharks are just so different, where they reproduce in such a different way. Like the way that they give birth is extremely different from other sharks, like other sharks of the same family. And also biologically, they're very different too. They're huge animals that just have this very elongated upper caudal lobe. Are just these huge teeth with these like kind of heart-shaped teeth. They're so omnivorous. They eat so many different things. So like overall, they just like look and feel and are different to such a extreme degree that they are their own family. So tiger sharks recently were reassigned their entire own family, Galeosotidae, indicating that this group of sharks has branched off from the other requiem sharks a long time ago, which makes sense. So it's really cool. So shark revisions of shark taxonomy have, happened, or continue to happen and will always happen. And it's kind of cool to see that the wobbegons are getting their own revision. So it's pretty interesting. We propose that the onset of diversification over electrolobid sharks or wobbegons is of Miocene age and occurred within the Indo-Australian region. Surprisingly, we also find evidence for a recent and rapid radiation of wobbegong sharks in the last 2 million years. So that's actually really cool that the wobbegons diversified, as far as evolutionary history, that is actually very recent, so quickly. And I have my timeline here. That would be the Pleistocene. So that is like the famous Ice Age era, which is kind of cool. So let's see. Rapid radiation of wobbegong sharks. Allopatric speciation followed by range expansion seems like the general most likely explanation to account for. Allopatric speciation followed by range expansion seems like the general most likely explanation to account for wobbegong relationships and distributions. We suggest that the evolution of this shark group was mostly influenced by 2 temporal scenarios of diversification. The oldest relates to major geologic changes in the Indo-West Pacific associated with the Miocene collision of the Indo-Australian and Eurasian plates. The most recent scenario was influenced by changes in oceanography and the emergence of biogeographic barriers related to Pleistocene glacial cycles in Australian waters. So that's extremely exciting. That is, it's kind of cool to see like how the glaciers had an effect on, or like how the great glaciers had an effect either directly or indirectly. I'm assuming indirectly on habitat availability for wobbegong ancestors and allow them to diversify. So it's so cool. Let's see. So I think there are some snippets of the article that we can read, and overall they do talk about shark evolution. So we can take a look at this. I won't read everything verbatim, but I'll just point out things that are interesting. So the elazobranchs. So elazobranchs are sharks and rays. They're not chimeras. Chimeras are their own kind of thing. But the elazobranchs are considered one of the most ancient and successful vertebrate lineages. According to fossil evidence, they were present from the lower Devonian, possibly Silurian, and radiated during the age of fishes to become widely distributed, represented by diverse morphological and ecological forms. They survived 4 mass extinctions, and most of the modern sharks are derived from the Mesozoic forms. So a lot of modern sharks actually can be traced to the Jurassic period, which is kind of cool. So I always love that there's like a relationship with like sharks just have this like feel and this look that it always makes me think of like Jurassic Park and dinosaurs and stuff. There's just something about them that has just such an ancient quality. They're so cool. But anyway, despite the highly successful evolutionary trajectory, the elazobranchs are relatively under-researched, probably owing to their historically low economic value. Maybe that, but also maybe because, I mean, there's such, a lot of them are just like, I don't know, sorry, I won't go into that because I'm going to save on time, but let's see. In recent years, improved recognition of the key role that apex predators play in ecosystem functioning, together with emerging conservation concern, has stimulated surge in research. Oh, actually, yeah. 1/3 of the world's chondrichthyan fauna described during the last 30 years was described during the last 30 years. So that actually really puts it in perspective. So you remember I said how there was like 300 sharks when I was a kid, and I was 500. That's what that relates to. So or refers to. Let's see. Let's see. Wobegongs are dorsal ventrally flattened demersal sharks that could be distinguished from other elazobranch families by the presence of dermal lobes on the lateral side of the head. These sharks are powerful ambush predators that occur over varied bottom topography and complex rocky and coral reefs to open sandy flats. Wobegongs are endemic to the temperate and tropical continental waters of the western Pacific and eastern Indian Oceans, but are most diverse in Australia. They are harvested as a food source at several locations throughout their distribution, including Australia, China, Japan, Malaysia. Let's see. There's 3 genera of wobegongs. There's Euchroserinus, Pseudorectus, and then Orectolobus, which is the floral banded wobbegong. Is that genus? It's the most Orectolobus is the most diverse genus. It could be distinguished from other genuses or genera by the absence of dorsal warty tubercles and dermal lobes from the lower jaw, and tall dorsal fins relative to body height. Let's see. I'm just kind of skimming to see if there's anything. I mean, this is a very interesting article, but kind of skimming to see if there's anything about kind of like the story of wobbegong evolution. Oh, thank you, Howard. Yeah, I mean, like it's so. I mean, like I didn't do anything, but like thank you for that comment though, because I agree. It is really incredible evolution, and like really incredible stuff to see. Where you know, I don't think we ever talked about woebegone evolution specifically, and it's actually really cool to see that they have a pretty unique story. So. Yeah, so they won't go into detail, but essentially, the root of shark evolution, modern shark evolution, is the Mesozoic era, and they said that woebegone evolution in particular diversified 2 million years ago. So I think with that, we could take a quick look, and this is a great resource as well. Love this website. So this is fossilguy.com. Amazing shark paleontology, like work done on this website. So it's a great summary of shark fossil hunting, but also a lot of great shark evolution stories as far as how sharks in general evolved, but also specific tales about how the megalodon evolved, and how white sharks evolved, what ancient sharks look like, and fossil concentrations in different parts of the world. So it's a great website, definitely recommend. But I feel like it'll be kind of cool to take a brief look at shark evolution, and we'll kind of zone in on the Jurassic and I think the Pleistocene to see what notes we can get from there, because it's a very long story. But so shark origins and evolution, we've got the Cladocellaceae era, genera. So these are kind of like ancient. I think there's a debate of whether or not these are actual sharks or chimeras, so, or something else. So let's see. First sharks evolved 450 million years ago from the Ordovician. Let's see. The Ordovician radiation, more impressively called the Great Ordovician biodiversification event, arguably rivals the more famous Cambrian explosion. During this event, Earth experienced an unprecedented explosion of new classes, orders, families, genera, and species, including the Chondrichthyes. It was evolution on steroids. So these are some ancient Chondrichthian scales, so really cool to see. Silurian, 443 million years ago. Not much shark fossils from this period. It's still really, really exciting stuff. So Silurian shark fossil diagrams here. The Devonian radiation of sharks, the 419 million years ago. This is really where I think the classic idea of ancient sharks is from the Devonian era, or the age of fishes. So what's actually really cool is that I think this is a jaw set of an ancient shark. So this is from Doliotis. It's not until the age of fishes, the Devonian, that fossil shark teeth and complete shark fossils appear. The world's oldest intact shark fossil is from a specimen called Doliotis problematicus, shown above. So this is the world's oldest shark fossil. It's unbelievable to think about. This is so cool. So again, this is the jaw set here. These are the jaws. And then down here is the pectoral girdle. So these are the pectoral fins right here. So the best preserved specimens and complete fossilized Devonian sharks are from the late Devonian Cleveland Shale near Lake Erie in Ohio. Some of these are so well preserved that muscle fibers are preserved, and even remains of prey in the gut can be studied. The Cleveland Shale contains a variety of shark specimens or several species of the streamlined genera Cladocellaceae, as well as other genera such as Diademotus, Stenocanthus, and Orotus. They look very different than modern sharks. They were smaller, shaped differently, and some even lived in fresh water. To the untrained eye, they looked more like fish and sharks. Below are some fossils from the Devonian. Carboniferous, the golden age of sharks. So this is Helicoprion. This is a famous prehistoric shark with this really weird looking whorl at the front of, well, in its lower jaw. So it's a very odd looking animal. There's a major mass extinction around 374 million years ago. A lot of the armored fish died, including Dunkleosteus. Oh, cool, Howard. I have some spines from the Silurian of Niagara. That's so cool. The extinction of Dunkleosteus. Some fossil enthusiasts might know this. This is like a nightmare fish, and it was the top predator of the ancient seas. So the extinction of this top class of predators left a large ecological hole. Immediately afterward, in the Carboniferous period, sharks seized the opportunity and became the top predators. The Carboniferous marks the high water mark of sharks. The Carboniferous is known for its huge coal forests and irradiation of amphibians, is also known as the golden age of sharks. So when amphibians came into the world, it was also the age, like the peak of shark biodiversity. So, and it's actually really cool to see some of the fossils here. Falcatus falcatus is a weird-looking shark. So its head is here, but you have this like very enhanced spine. It's kind of wild to see. The Permian, the near extinction of sharks 298 million years ago. So the Permian extinction was, I believe it's the worst possible extinction that has ever happened in Earth's history. It's like twice as bad as the meteor that killed the dinosaurs. It's really bad. During the next period, the Permian, some of the more specialized shark genera became extinct. Everything came to an abrupt end at the Permian. The end of the Permian is marked by the big one, Earth's largest mass extinction ever. This extinction was so large it was used to mark the end of the entire Paleozoic era. Life on Earth looked fundamentally different after this extinction. The common animals that existed for 100 million years vanished. After the Paleozoic era, there was no trilobites, horned corals, or spiny sharks. Any surviving life was severely reduced as 80-95% of all species became extinct. Causes of this extinction are linked to an abrupt climate change. The specific causes are still being debated, whereas the formation of Pangea, extreme volcanism, other geologic activities, an asteroid, or any combination thereof does not change the fact that almost all life of Earth was wiped out. Life barely squeaked by this one. Sharks barely survived the Permian extinction. One of the better known sharks in the Permian is Orthocanthus, a large freshwater eel-like shark. Wow, I didn't even realize it was a shark. I thought this was an amphibian. So this is... And I think, Howard, you may have... I think you did draw this at one point, which is so cool. I forget if you drew Orthocanthus or Stenocanthus, but it's unbelievable to think that's a shark. Wow. So, Orthocanthus shark fossil. It really does look like a bony fish, honestly. Falcatus from Bear Gulch, Montana. Wow. Oh my gosh. Yeah, this is such a strange looking animal. I'm trying to move on, but like it's just still blowing my mind, like how this is possibly a shark. This is so different from what we think about. Sharks do have fin rays, so even though sharks have the thick cartilaginous fins that we all know and love, where it looks like a single fin, the inside of sharks' fins are rays, so these are rays of cartilage. So that is true. And it looks like this particular shark has a very long dorsal ray, kind of like frilled sharks. This is why we describe frilled sharks as some of the most ancient looking sharks. It's actually kind of similar to this species here, so very interesting. So, Mesozoic, modern beginnings. So these are kind of the famous dinosaur periods, so 252 million years ago. The Triassic period is an interesting time for life. Dawn of the dinosaurs. A lot of giant marine reptiles. These sea monsters are fierce predators that ruled the Mesozoic oceans. The surviving sharks took a backseat to these terrifying beasts. So, let's see. They continued to diversify. By the end of the Jurassic period in the Mesozoic, all 8 extant shark species orders appeared. Okay, there we go. So, I'm going to reread. Actually, I think I'll read this whole section because this is such an important period for shark evolution. So, the first period in the Mesozoic era, the Triassic, is an interesting time period as life on Earth began a slow recovery from the Permian mass extinction. The few surviving taxa, both on land and sea, radiated and diversified, creating new ecosystems. Although mammals make their appearance, reptiles were the main creatures to dominate these new ecosystems. They dominated the land via dinosaurs. They dominated the air via the flying reptiles like pterosaurs. They also dominated the seas with a new terrifying kind of animal, the great marine reptiles. So like the famous Jurassic World Mosasaurus is this era. You have Elasmosaurus, you have the Ichthyosaurs. So marine reptiles are the rulers of the ocean. These sea monsters were fierce predators that ruled the Mesozoic oceans. The surviving sharks took a back seat to these terrifying beasts. Although sharks took a backseat to the great marine reptiles, they continued to diversify and took on their modern-looking characteristics. By the end of the Jurassic period in the Mesozoic, all 8 extant shark orders appeared. So, it's so cool to see that, and it's so important. So these are the Eucelaceae, which are the modern sharks. So this is the same group of modern sharks that we all know and love today. So the orders are Carchariniforms, which are the ground sharks, Lamniforms, which are the mackerel sharks, Orectolobiforms, which are the carpet sharks, like the floral wobbegong, or floral spotted wobbegong is a carpet shark, or Orectolobiform, Heterodontiforms, which is the bullhead sharks, Squatiniforms, which are angel sharks, Pristiaphoriforms, which are the saw sharks, Hexantiforms, which are the cow sharks and frilled sharks, and then finally Squaliforms, which are the dogfish. There's also Echinorhiniforms, which was recently split off. Those are the bramble sharks. So they kind of, in the theme of like shark taxonomy and revisions, bramble sharks are given their own group. So, let's see. At the close of the Mesozoic era, at the end of the Cretaceous period, a great mass extinction event took out most of the reptiles. The dinosaurs, flying reptiles, and great marine reptiles all disappeared. This allowed sharks to once again become top predators. So it's incredible to see Cretaceous shark teeth because a lot of these look pretty unchanged. Like some of these this looks like, almost like a tiger shark tooth. This almost looks like a straight up mako shark or sand tiger shark tooth. Wow. Okay, so we've got an extinct goblin shark, Scaphanorhynchus. Squaliocorax is an extinct crow shark. Tychodus, which is here, is a shell-crushing shark. Cretolamna is a mackerel shark. So it's like there's so much going on here, and it's kind of incredible to see how modern-looking these teeth are, where a lot of these teeth, like, you can see in modern sharks today, specifically, actually all of these teeth types. You can actually see all of these teeth types in modern sharks today. This one is a little weird, but everything else actually you can find today, which is pretty amazing. The Cenozoic, the rise of giant sharks 65 million years ago. So there's the infamous the Megalodon. So during this new era, the Cenozoic, a new food source appeared. Mammals returned to the oceans, which are the form of whale dolphins. It's a new and easy food source for sharks. As results, modern-looking sharks grew. You got the birth of the world's largest and most fearsome shark, the megatooth shark. So megatooth is not the same as megalodon. A megalodon is a kind of megatooth shark, but there's actually a group of megatooth sharks. There's a couple different species that actually are in this category. This beast originated in the Paleocene with the Otodus genera and slowly became larger and larger through time until apex species emerged in the Miocene 23 million years ago. Carcocles megalodon. Think of this giant megatooth shark as a 60-foot great white. Other sharks during this time period also became supersized. A good example is the giant white sharks, Cosmopolitodus, These are non-serrated, larger versions of the great whites. Luckily for humans, the large sharks became extinct at the end of the Pliocene extinction event about 2.5 million years ago. Okay, so that was a mouthful, but this is really cool. So the giant great white sharks went extinct 2.5 million years ago, and what's interesting is that the wobegons diversified 2 million years ago. So you have to wonder what caused the giant great whites to go extinct, and what caused the wobegons to flourish. And I don't think they're quite related. They might be kind of related because wobegons do occupy a temperate space, and we know that white sharks do live in Australia, so there might be a kind of relationship there where just as conditions were getting worse for giant white sharks, they were getting better for wobegons, so that there could be some kind of interplay there, which is pretty interesting. But here are some Pliocene shark teeth from giant sharks. So there's a megalodon tooth, which is actually really cool to see, where this burlette, this little dark area here, this dark V shape, is how you can tell a megalodon from other kinds of shark fossils. So these guys are megs. The ones with the burlette are either megs or closely related megatooth shark species. So these three fossils right here. This is more of a great white shark of some kind, like an ancient white shark. So, because they don't have the burlettes, and they also have very distinct serrations. So the serrations on the side typically indicate it's a great white of some kind. And I don't like saying great white, because great white is like the modern Carcharodon gregarious. So this is probably like, you could say an ancient white shark. I do have Carcharodon tilis teeth, Carcharodon stalis teeth. These are like the prehistoric white sharks, so like narrow white, and I forgot the common name for the other one, like the giant white shark. Conclusion, the fragmentary fossil record shows that sharks originated sometime Ordovician. The fossil record also shows sharks continue to evolve and change. Many shark designs from freshwater forms of sharks with bizarre shapes and even giants like common climb. These adaptations allowed sharks to survive every mass extinction event and thrive to the present day. So, really cool article from fossilguy.com. I actually want to go into, if we have time, I know he does like a really cool summary of white shark evolution, and I want to see if there's a relationship between white shark evolution and wobegon evolution. So, colors of shark teeth, types of shark fossils, megalodon evolution. I guess we could try megalodon evolution, because that might really... I know there's a great article here about white shark evolution. So we're going to skip the meg stuff. This is a really cool... I'm going to put this article in the chat because I actually do love this a lot. So this is a really cool evolutionary lineage of megatooth sharks versus great whites. So a kind of unfortunate myth is that great white sharks and megatooth sharks are closely related, and the reality is they're not. Megatooth sharks kind of are their own thing, so that's exemplified here. This bottom line is the evolution of megatooth sharks, and megatooth sharks went extinct in the Pliocene era. But over here is the evolution of white sharks, and what's kind of cool about white sharks is they're actually hyper-evolved mako sharks. So a group of mako sharks grew into the modern mako sharks that we know, like the short fin mako and the long fin mako. But another group of mako sharks got fatter and bigger and more interested in hunting seals, and they eventually evolved to become the white sharks. And there's only one living species, the great white. So it's kind of really cool to see that. But I want to see if they have any notes about how white sharks evolved. And specifically if it relates to any kind of global events. Let's see. Okay, I think this might be it. Let's see. So I think this will be the last thing. The development of megatooth sharks could be traced back into the Cretaceous period, as been mentioned earlier, is directly linked to the development of other animals. In the Cretaceous, not only sharks but also marine reptiles ruled the waters. This condition changed, however, after the extinction of the dinosaurs in favor of the sharks. Sharks now occupy the ecological niches for predators. Additionally, the basis for a more energy-rich nutrition was created by the rise of marine mammals in the Eocene. Hence, the reasons for functional morphology, the appearance of serrated cutting edges in megatooth sharks is strongly linked to the evolution of whales. For example, the ancestors of baleen whales. During the late Oligocene, 30 to 25 million years ago, the ancestors of baleen whales have been exceptionally numerous at times, the climatic conditions being much more favorable. Temperatures were significantly higher than they are today. Tropical and subtropical waters reached much further into the higher latitudes of the polar regions. During the following epoch, the Miocene, and that's where I get a lot of shark fossils from, kind of where I live. A lot of the formations here are Miocene. Modern baleen whales developed and spread more and more. There was an obvious increase in size in whales and simultaneously in megatooth sharks, which could be explained by better nourishment of the whales. During the spreading out of the whales, it presumably reached cooler polar waters that provided them with a richer food supply to which the whales adapted themselves. The whales were migrating between cool water feeding grounds and warm water breeding grounds. The climate became colder at the end of the Miocene and at the beginning of the Pliocene, about 5 million years ago. The ice cover of the Antarctic polar region grew bigger and the mean sea level dropped. The living conditions for the habitat for Megalodon, who probably loved warm waters, obviously restricted to such a degree that the species became extinct during the Pliocene. At least this is what the fossil record says, meaning the fossils of megatooth sharks are lacking in the corresponding layers and places. This is where the evolution into a specialized super predator obviously led to a dead end. So, interesting. So, and they did talk about, for the Wobbegong evolution, this is interesting. I know it's kind of like a little bit different, but oh no, that's not it. Where is this? Wobbegong evolution. There we go. Ooh, Howard, where do salmon and porbeagle sharks work into the picture? Great question. So I think they are lamnids, so they are in the same family, but they must be very distantly related. We can actually take a look at where's that chart that I had? There we go. We can actually take a look at that here. So, okay, so we've got Carcharodon carcharias, the great white. And then, actually, this is pretty interesting. So, you have okay, here it is. So, you have Isurus paucus, this is the longfin mako. And then the great white kind of evolved from that. But you can actually see that the lamna sharks, so the porbeagle and the salmon shark, actually evolved from the great white lineage. So just as the great white kind of became a really fat mako shark, it looks like the lamnas, like the great white, the salmon shark and the porbeagle, kind of became these like smaller, compressed great white sharks. So it looks like they evolved within the great white shark lineage, which is so cool to think about. And it kind of makes sense where maybe as larger predators became less available, maybe selection was selecting for smaller, more compact sharks as successful survival strategy. It's so fascinating to think about. Wanted to reread the Wobbegong quote. So let's see. Okay, we discussed. Okay. Oh wait, no. I think they mentioned something about Wobbegongs here. We propose the onset of diversification of Wobbegongs is of the Miocene age and occurred within the Indo-Australian region. Surprisingly, we find evidence of recent and rapid radiation of Wobbegong sharks, followed by range expansion. Seems like the general, most likely explanation to account for Wobbegong relationships and distributions. The oldest really suggests the evolution of the shark group was mostly influenced by two temporal scenarios of diversification. The oldest relates to major geological changes in the Indo-West Pacific associated with the Miocene collision of the Indo-Australian and Eurasian plates. The most recent scenario was influenced by changes in oceanography and the emergence of biogeographic barriers related to Pleistocene glacial cycles in Australian waters. So there is a relationship here where they're talking about the Antarctic ice sheet getting bigger, or the polar ice sheets getting bigger, and pushing the megalodon's habitat out. Megalodon wanted tropical waters, and as the ice sheets were getting bigger, it was getting less wiggle room, and the whales could be in these like polar areas, but the megalodon shark really couldn't access them as much as it used to. And then simultaneously, there's something about that formation of the glaciers and formation of ice sheets that influenced how wobbegong sharks were able to radiate. Unfortunately, I can't see the whole article, so I'm not exactly sure how they relate, but I think there's something kind of there, which is so cool. I mean, there's a lapse of 500,000 years, so I gotta be careful about that. But it's really interesting to think about that. Just as something changes for the downfall of a shark group, it also created that change helped give rise to another shark group. So it's kind of cool to see that in a weird way, wobbegongs flourished as megalodon declined. So it's so cool to think about. But it's 11 o'clock, so we'll wrap up for tonight. But guys, thank you so much for watching, and I'm going to repost the rig's scientific name, which is so exciting. Rig musculus lenticulatus. Okay. I actually really like that. So hound sharks are a really great group, and I'm very excited to cover one for next week. I'm also really excited because the rig is going to be the last stream I do before I get married. So this will be, the rig is going to be the last stream, and then I'm going to be off the following week, and then we'll come back for a new shark. I think that is September. No, that might be October. Let me make sure I got that right. So we got one more. Oh, it is September, actually. So I'll come back September 29th with a new shark species. But next week we'll have the rig. I'm very excited. It sounds so cool. I love that name, like the rig. It just sounds very intimidating, although hound sharks are not intimidating at all. They're actually really cool sharks that are harmless and related to leopard sharks. There's such a cool look about them, so I'm very excited to learn more about them. But guys, thank you so much for watching. I hope you have a great week. And Ray, thank you so much for joining. Welcome to the channel, and welcome to this really great community of shark lovers. I hope you guys enjoyed this episode, and tune in next week for the rig, the last episode as a on tax form single person. But cheers, guys. Hope you have a great week, and thank you so much for watching. I'll see you soon. Bye.